Well, good morning, Powermetrix Nation. We are excited to continue our live field testing series this morning. We started out with that kind of super teaser that we had at this first site that we're showing is an 8S site. So we're going to be talking about the continuation of that. There's going to be 3 parts to this. So we're going to do part 2 today, and then next Tuesday will be part 3, and we'll finish it up. We are pretty excited. We want to take our time with this because obviously it was an unbelievable privilege and a blessing to be able to do this live in the field. And so we've got a lot of footage and we don't want to fly through it. So we're going to take our time and we're going to cut it into pieces where we can get as much training out of it as possible. Both on some of what you're going to see upcoming is going to be pretty technical and make you think a little bit, and then also we're going to start with some very basic stuff. So because we know we have all level of experience out there of meter techs that are watching this, so we don't want to just jump straight into the tall weeds. We want to go ahead and start out with some good, just basic information, because really honestly for us at Powermetrix, it's as much about safety as it is anything, and honestly it's the most important thing. So none of this, as you've seen, has been about sales starting back how many webinars did we do, JP? Okay.
I think we got to be close to 70. I haven't counted them in a while, but we're between 60 and 70. I'm certain of that.
Wow. Okay. You lose track after a while, and then I'll have to go out of town and come back, so I wasn't even here for some of them. But so it's a lot of these, but this has all been about training. Hadn't been about selling. And we're pretty proud of the work that we've done. I'm very proud of the guys that I've gotten to work with. They've just done an unbelievably professional job, and so I'm just thankful for all the guys. So this is actually the 2021 webinar number 11, and as I said, today is part 2. May 4th next week will be part 3. It won't be live. We're going to film it today because I'll be at the Mid-South Meter School up in Gatlinburg next week. So this will be we'll film it today, this afternoon, and then that's what we will show on the 4th. Now on the 11th, I will be back in town, so I'll be able to do it live. But so that's what's upcoming. Just so you guys can see, this is a birthday card from my mom, and my mom's go-to for me is fleeces. For birthdays and Christmas. So I've got a lot of fleeces in my house, still have the tags on them because I've gotten a lot of fleeces over the years, and it's not like you wear them out that fast. So this was another bag she gave me back in March for my birthday, and it was I could see the fleece and stuff and in a bag. I didn't notice this until later. This was the birthday card that was in the bottom of it, and I thought you guys, this may help you understand, those of you that know me, where I get my sense of humor from. So it says, once upon a time, a very special person was born who is destined to change the world. Then I opened it up, and it said, calm down, it's not you, it's Jesus. So it said, but I think he'd want you to have a happy birthday, though. So I thought that was pretty funny. I thought I would show that to you. I showed it to my men's group at church and stuff, and they got a kick out of it. So, yeah, that's where I get it from. If you're curious, I came by it legally through Mom. So you've got, we've shown this a lot of times. You're used to seeing this. We've got some this week, as a matter of fact, some more of our training demos that we're going to do for folks. You can also get a product demo if you like. If you want to see a certain product, we can show that to you. But the training demos using the bench behind me, we've done a lot of those, and we continue to do them. And actually, in these times where it's up and down with access and then no access, and access and no access, you can really use these demos really well. And as a matter of fact, we've got one upcoming we're going to do for some guys in Canada. So we can even do it international. So if you want to utilize that and get some training, please contact us. And what's the best way for them to contact us on that, JP?
Either email you or me.
Okay, email either myself at john.jones@powermetrix.com or email JP, which is Jarrett, Jarrett, Peters, Jarrett.Peters @tec-usa.com. And so you can send it to either one of us, and we'll get you a video, a conference lined up, and get one of these so we can do specific training for your company on even just one particular meter or one particular piece of equipment. Okay, so as I said, we've got some of these upcoming. As a matter of fact, we've got one tomorrow for some folks in Massachusetts, and then we've got one coming up in Canada. So we can do it international, and not that Massachusetts is international, but I have a hard time understanding them sometimes. So I'm gonna catch a grief from the guys up there about that, but that's fine. Here's the agenda for today. We're going to talk about test equipment setup, service type detection, meter nameplate information, connection methods, and then verification of those connections. And so before we jump into it, I'm going to go ahead and pray, because I'm known to do that. So we're going to go ahead and do that, and then we'll jump right into it. Father, thank you so much for this time today to offer information to those folks out there that have become family to us. We want all of them to get home to their families. And so if we can do anything in this series that helps someone not make a mistake or do something safer so they get home to their families, all of the work's been worth it, Lord. So we ask that. We want everybody to get home to their families. And Father, in these times, it's just, there's just so much stuff going on in our nation right now, but it's just, I would hope that we would understand as Christians that we're on the winning side. So responding either negatively or even with some anger to any posts or anything like that, there's no need to do that, no need to get involved, because we put our trust in you. And as I said, we can, I'm stealing this a little bit from my pastor, but we can either be victims or victors, and we're on the winning side in the end. When all this is said and done, we're on the winning side, so we should be acting more like victors than victims. We don't need to lash out. We don't need to on the computers and even in the things that we say. Instead, we just need to be there for one another, come alongside one another, and love one another and show that kind of love, brotherly love to everyone out there. So hopefully we can do that. It's tough because the world wants to push us that way, and our weak flesh gets involved. But Father, hopefully we'll turn to you, get guidance from the Holy Spirit, and it'll help us to be more loving and encouraging to one another instead of some of the things that we're seeing on TV. So, Father, but all of that became, and the ability for us to even repent was all made available by the sacrifice that your Son made on that cross. So right now, I say and ask all of these things according to the will of the one who paid it all, my brother, Jesus Christ. Amen. Cool. Okay, so what we're going to do is we will show parts we've got here on the screen, and JP, as always, has got a lot of cameras set up, and we've got a whiteboard over here we're going to use at times. But on the screen here is going to play the video from this site, and what we'll do is as it plays, I'm going to stop and talk about some things and point some things out because the clarity that JP got is unbelievable, even up there at the top of the pole. So we'll be able to point things out, and we'll just, so as we go along, we'll stop, take some time outs, talk about stuff, and maybe even draw something on the whiteboard over here. So without further ado, I'll let JP go ahead and get this thing started. And then, as I said, we'll stop as we go along and talk about some things, okay? So what are we looking at here, Brylan? If you're looking at the service here, and let's go back to what we were told. We were told that this was a Y, right? So if we come out here, I'll get JP to follow me out here for a little bit. When we walked up, okay, with all the experience that Brylan's got out there in the field, he knows better and trusts what somebody tells him, so he's going to look up there and take a look. And immediately, what did you notice on the pots, the size of them?
I noticed you've got two pots that are the same size over here, and then on the pot where it's just the one on the right side, if you're looking at the camera right there, it's a different size pot. And most of the time on your Ys, when you just have a straight Y, you know, all your pots are the same, they're tapped the same, whole 9 yards. So I knew something was up there. So then we come over here to the meter.
Okay, we had a little discussion afterwards and did a little recap on the site, and here's some things we came up with. If you look back a little bit historically on the meters, you know, of course, there are electromechanicals, and now we've gone to electronic meters almost exclusively. As much as you can, you want to change them out, it seems like. So back in the past, you had on the electromechanicals, the 9S meters only handled 120 volts. The 8S electromechanical meters handled the other voltages, right? So now if you go to today with the electronic meters where they're auto ranging, that's why you can have one meter that can handle several different voltages. And if you actually look on the face of this meter right here, let me get my glove on to be proper about this, and I'll let JP zoom in here. If you look right here, where we always look right up here on this left side to look for our meter forms, notice it says 9S, 8S. So the difference being when you have...
Okay, so one thing that I wanted to mention, I say there I better get my gloves on. It was pointed out to me in the previous teaser that we sent out where we were just assessing the pole and the site there, that when I had that top cover in my hand, I was holding it without a glove on. Okay, and I showed where I got close enough where I showed that the top cover and where it was positioned, in the can. You would not want to do that, and so I don't mind pointing out where I don't have a problem with that. I should have had my glove on when I did that. Okay, so that would not be a safe way to do that. And for the library and moving forward, I'm actually going to get JP to cut that little part out there because that is not a safe practice to not have your glove on. Even though I was just holding the cover and standing out there, I reached forward to show, and I got it close enough to that can and that meter to show where it was positioned on the meter. I should not have done that because really, and I'm not saying you don't see that and that it doesn't happen out there, even when you go up there to cut that seal and open that thing up, you should have your gloves on. So that was something I wanted to point out from the last one, that you do want to have your gloves on. Even when you're cutting that seal and first going into that thing, you want to have your gloves on. And I didn't have it on there for that top cover when I was showing y'all how it was positioned on there. And that was a no-no, and I shouldn't have done that, okay? For safety's sake, I should have had my gloves on, okay?
A Delta service like this, it actually is an 8S that we're using here, okay? So this is actually, if you were going to pick the proper form to be on the test and pick the proper form to put in the machine, if you come over here, I changed it and went from a 9S to an 8S. And when you go to an 8S right here, it actually defaults to a 4-wire Delta, which is exactly what we had. But when I went in here, I had to change this. It defaulted to a 2-voltage 3 current. I just hit my drop down, and heck, I may as well show you while we're here. See here, your choices, it defaulted to the 2 voltages and 3 currents. So we just went down and we chose 3 voltages, 3 currents. And then that put us right, okay? So it defaults to 2 voltages, 2 currents. So you go down to right here, then you choose that. And that would be how you would actually want to run the machine on.
Okay, so you notice on the machine, when you chose 8S as the meter form, and it defaults, we got 4-wire Delta here, because remember what I said, if you looked in the corner of the, we'll come over here, if you look over in the corner of that meter, it showed 120, 480. Okay, that's what we mean by auto ranging. So what that means is that meter can handle 120 volts all the way to 480 volts. Okay, so that's what we mean by auto range. It can be used on any one of those voltages between 120 and 480. Okay, but as we said back in the day, it wasn't that way. So now you have to think a little bit about which meter form you're going to choose to enter into the machine. I do know some people that they'll just go with a 9S, even though it technically is an 8S, they'll pick a 9S and they'll choose their 4-wire Delta and go off of that. Okay, but really it's not. Okay, it is an 8S. And if you come over here and look, the choices that we had when we first chose an 8S and a 4-wire Delta, the machines that you have are going to have a default that they go to, right? It's just like when you choose a 9S, it goes to a 4-wire Y, on the machine. And so it has a default to kind of speed things up. It's going to automatically choose a service for you, and it's typically going to be the most common service. So if you try to use a 9S on this, it would default to a 4-wire Y. You would go down there and choose a 4-wire Delta. But when you choose an 8S here, it defaults to a 4-wire Delta, which is what we have here, okay? And then it also says right here, it defaulted to a 2 voltages and 3 currents, okay? But as you can see here, that's what I'm not going to choose. So go ahead, JP.
this site, because this is acting as an 8S, and it is it's a Delta, and it's that high C leg. And so remember, when you choose the 8S on there, it's going to default to a 4-wire Delta. But look, this is where, and we've talked about this some, and we'll talk about it more on service types. You got to make sure you get the right service type, your number of voltages and number of currents. And in this case, we've got 3 voltages and 3 currents. Got 3 pots. We've got 3 currents coming in here, down here at the bottom that we saw at our test switch. So you would have went to the other option, which was 3 voltages and 3 currents on the 8S 4-wire Delta. And that is really how you would want to enter this site in. But that's a little bit of the history of how we got to that point. With these auto rangers, you still want to put the correct meter form in there for how it is being used at that site. So in this case, you're using it as an 8S 4-wire Delta high C leg, okay?
Let's stop.
And you can see up there, once again, in the right of the screen right there, the Delta symbol. And it's also 240. So I knew then, all right, we've got a high C leg right here.
So that is what we have.
So what you're going to see in the corner there of the screen is it's going to either show you a Delta or it's going to show a Y. And that tells you the configuration of the service you've got there. You've either got a Delta service or a Y service. If you notice there beside that, it also shows you the max voltage. In this case, it was a Delta, and it showed you 240. So that's a 240 volt Delta. Now let's say you saw 480 on that screen for a service. Typically, you're not going to see that. Why? Because most people are going to PT down from 480. If they do happen to still have 480, you'll see 480. But most of the time, just kind of a key for you would be is if you saw 120 on that screen, what you should think, and remember we got this Rolodex going in our heads, chances are you've got PTs involved. And remember, we've talked about PTs. In other words, if you have 480 volt primary and you use a 4-to-1 PT up there, that's the ratio on that potential transformer. What it does is it takes that voltage down by 1/4. So if I've got 480 on the primary and divide by 4, I end up with 120 volts, right? So that's why you would see if you see 120 on that screen, chances are you've PT'd down 480 volt to get to the 120 volt. Okay? So then what do? You look for the PTs and see if the PTs are up there. Okay? And then depending on your utility, are you going to test the PTs or not? And that gets in, that's up to you guys. But if I see 120 on there, chances are, right, I have PT'd that down from 480 to 120. So if I see 240 on there, and it is 240 volt, okay? So I know what I'm dealing with at the bottom of the pole there. So it's a 240 volt Delta as you saw on that screen right there, okay? Yes, sir.
So you've got the larger pot on your C leg because it is for your high C leg at this service.
Right,
so that's why you've got A
so
and B
you notice
same
that we've
size.
got 2 pots the same size and 1 pot, we went around to the right side. So you can see we've got the one larger pot over there. So then that tells me it's a high C leg, right? Because I've got a larger transformer than the other 2. So if I'm anticipating a high C leg, I'm kind of already thinking in my head what I'm going to see as far as the vectors, okay? So once again, we kind of get all this going on our head. We've assessed the pole in the beginning. We've looked for any issues with the pole, but we've looked up there because you don't want to trust what's on the paperwork. You don't want to trust what someone's told you. You trust this and this, right? So you go out there, you look at it, and you assess which service type it is. Because like I said, in this case, we were told it was a Y, and it wasn't. So when you see one of the pots is larger than the other 2, then you're thinking high C leg is what you're thinking. Okay?
Is a larger size pot up there. All right? So now that we realize what we're dealing with, which is a Delta, so we're looking at how this thing how we've got it across here. And I guess another thing to notice is, we were talking about it just a second ago, you can see some crud across the top there. This would be one, if I was reporting, and you probably would too, Brylan, I would let them know and say, hey, this might be one you might give a little attention to. You might want to check it out across the top here. We found dirt and all this other stuff in here. So you might want to just next time you're in here try to check this one out. Because you got all those spray cleaners, different things you can spray stuff on now, and it wouldn't take but a minute just to clean stuff off in this one.
Okay, some things about this site. This is a site that's over 30 years old. Okay, so one of the things we talked about in the previous, the teaser was about that pole ground. And I just wanted to say that over 30 years ago, like I said, the way that they had run their ground into that can was they started with the pole ground up at the top of the pole. They came down through the conduit, and then when they came down to the test switch, they just came in and looped around into the returns and went to the actual ground in the can. Okay, so it was internal through the conduit. Whereas now general practices is to come from the actual pole ground, running down the side of the pole, going into your stake, into your stake rather for your earth ground, and running it externally over into your can. So it's not wrong or right. It's just practices for that time. And as I said, this one's over 30 years old. So at that time, that's the way they did it on some of these sites. So previously, when we noticed that wasn't run over there, and we pointed that out, that may be one that if you go to upgrade that site, or if there was a storm or damage and you were going to replace that stuff, probably you would go to now the current practices, which would be to come from the pole ground and run it externally and come up into that can that way. So this is how they did it back in the day over 30 years ago on some of the sites. Okay? You'll also notice, and I don't see JP if we roll it a little bit more. I wanted to talk about the way he's got his equipment set up here. So let's run it just a little bit farther and see if we can see the way that Brylan's got his equipment set up. If it backs off a little bit, I want to point that out.
You might want to give it a little more attention, because it's when you try and actuate those blades in there, they're pretty tight, aren't they, with all the corrosion?
I'd say they will be.
Yeah, I think so. And one quick thing too,
okay,
is when you're looking at this,
let's just stop right there, and I'll talk about it. So you'll notice here that the piece of equipment that he has, it's got the load box and the actual test kit are married together inside the case. So it's not handheld with that load box. You can get equipment that is handheld, but in this case, the two of them are married together. So you notice what Brylan has here is he's got a table set up. We've got folks that make their own handmade stuff. They'll go get them a folding table from a store, or they've got just a simple folding table like this. But you'll also notice what I like is, and these guys that have done this a lot, before he really gets rolling, he has his cables separated. He takes them out of the case, and he has his alligator clips hanging over you see where he's got his stuff hung over the lid here. He's got his alligator clips hung over there for his voltage. He's got his duck bills hung over there. He's got his flex hung over there. So they're ready to go, and he's not, once he starts into the test, he's not fishing stuff out. He gets everything set up. So there's like a pre-setup before you get going. So he's got a table to get it at a nice height instead of leaving it on the ground, which can be kind of a pain in the neck. And if you're doing a lot of these in a day, rough on a fellow's back, right? So he's got it up on a table, but he's got those cables hung over the back of that lid, so it makes it easier for him to just take them and start making his connections there at the inside the meter can.
I got to be careful not to just think colors, because when I'm looking at this, it looks like maybe everything's tied in on my B phase. You might think that that's all tied into the neutral, so maybe if you're looking at it, think it might be a B grounded, right? Because you're thinking, I'm hooked right here with this white into this ground, but this has actually got a black trace on it if you look at it on the back side. So you can't go by the colors. You got to go more by actually looking at how this thing is wired and what service you got, right?
Yeah, you can trace that wire right there. It runs up and comes up into the meter itself.
That's exactly right. So don't confuse it and look at it. You know, I looked at it a minute ago and I was looking at it and I was thinking white. I'm watching all these white wires. I got to make sure I don't think that way, right? You actually trace the wire a little bit, look at the wires, think about the transformers at the top of the pole, and think about your service type, and then it all makes sense, right? So it's going to be a 9S. It's a high C leg like Brandon chose in there. It's the delta, so it all makes sense, and it's 3 voltages and 3 currents. So if it's 3 voltages and 3 currents, then you're not going to have either an open, nothing's going to be open delta, so you're going to have something on B phase right here.
Yeah, let's stop it right there.
It is that.
Slip of the tongue, I said 9, it's an 8. Okay, so it is an 8. We've already clarified that it is an 8. I don't know why I said 9. So trying to keep everything in my head that I wanted to make sure I covered on this thing. And that was just a slip of the tongue, so I know that someone's going to say something about it. So I know that it's an 8. I accidentally said 9 right there. Okay, go ahead.
White wire, but that is a good wire. It's not my actual, also my looped return wire. Cool.
Another thing, when I'm hooking these up, I like to grab the blade right there. I don't want to come down here and grab the little tabs down here at the bottom, because all you're getting is just this little piece right here. And look, actually this one's missing. That you got the bottom side right there, but the top side's missing. So if you're on that blade, that's barely getting a good connection. And you always want to look at these tabs too, because they can get bent down, and this is a perfect example of where this one's missing right here. And really and truly, that ought to have a new clamp on it and not have to worry about it being able to get a good connection in there.
You know, because the end of those teeth, it's got 2 upper and 1 lower, and they just kind of engage like this, those teeth on the end, but those teeth on the very end tend to get broken off, just what Brylan's saying. So that is a good point. If you look at them and you got the good teeth on the end of them, it might be okay to get on there, because that one tooth will get up and grab up in that hole, right? So you can grab in there and get a hole in the end of that tab. So it'll grab on there for you. But if you don't have a teeth on the end of it, so maybe you just make it a general practice to get on those blades if you can. The other part of it is, if you noticed what he's doing, he can get more contact and he can work on that blade a little bit if he's got corrosion involved. So he can work that blade, he can work that alligator clip back and forth on that blade, and he can get more surface area that he's making contact. The other part of it is, if you ever have to get at the top while he's connecting up, I'll just say this, if you're ever going to supply voltage, right, and you got to, so if you think about it, I'm opening the switch up down here, and I'm going to grab it on the top. When I grab on the top of it like that, it's kind of that same principle of I'm just not grabbing a whole lot right there. So I'd much rather get on there a little bit better and try and get as much surface area contact as I can, okay?
Okay, we can stop it right there. So can you get in on this? Can I put this where you can see this alligator clip? Or if I get up here? Is that cool? Okay, so you can see here what we're talking about there on this alligator clip. There is a piece here that goes in the center between the two teeth right here. So it literally does have where it bites and grabs in between there. And if it bites and grabs and goes through that hole, if you have tabs that have holes on the end of them, then that works just fine, because if you actually grab onto it, and you're going to see it, we actually do this during the series, you can pull, it's in there good. But in his case, see, it had broken off, that piece right there had broken off, so it's not going to make a good connection when you try and just get on the end of it, okay, if you just try and get on the end of it in that hole in the tab, okay? So it's not going to make a good connection. So that's why he's just made it a general practice to actually work that on there, coin those surfaces, right, between these teeth and that blade, because there's a lot of corrosion in this area that we're in. So if you coin it by moving it back and forth there, you make a good connection, metal to metal, and you're cutting through that corrosion, but also that's a good practice if you don't have these teeth here. If you do have them, it's okay to grab in that hole, but and you decide this, everyone's going to do things differently. You're going to see later in the series, one of the other texts that we have, he likes to grab and go on the end of it, But you have to make sure you've got both of those end pieces right there, or it's not going to work very well. You're going to have issues, especially if they break off, okay? Okay, let's stop right there. So, well, crud, I wanted to get on the switch, so that's fine. Let's keep going. If we get on the test switch again, just stop it for me, okay, JP? If we get up in the can. All right.
Brylan opened up the, right then, if you saw him, he opened up that voltage blade, that potential blade right there, because this being a Landis and Gear meter, you have to supply power to it to start getting pulses actuated out of here. It's come out of your hog nose or your COM port right here. So what happens is, when you give it power, when a Landis and Gear meter receives power, then it starts emitting pulses, but after a while it times out and it stops emitting. So when you're putting it in a test board, that's fine, because you're applying power to it and you'll start getting pulses. But if you go out in the field, the one that's been sitting out there for a year, it's not going to be emitting pulses when you show up. And if you just connect it all up, you'll be sitting there waiting forever to get a pulse, and you're wondering what's going wrong. You just need to open one of those blades up and supply power to it. Now, if you hook your occucoupler up to it, and you're going to sit there and go, okay, and you're going to put it in test mode, that's fine. But unless you do that, you've got to actuate and give it power, and if you don't, then you're not going to get pulses out of here, okay?
And here we are at the vector screen. Before we even went into the integrated sight test, We're just checking everything over. Everything looks good on A, B, and C. And another thing, as you can see right here on your...
Okay, so let's talk about vectors for just a minute. So we're going to go over here to the whiteboard. So we had mentioned earlier about the high C leg, right? So we mentioned the high C leg here. If you look, you'll notice right here, we talk about there's the amplitude, there's how long that the vectors are, right? So you've got the length on the vectors as well as you've got their relation to one another. So we'll come over here to the whiteboard. Okay, so when you look there, you can see we start here and we go A, B, C on our vectors, right? And I've got, I know the yellow won't show up very well, but I'm going to go ahead and draw these. So I've got, if I draw my vectors, I've got, that would be my A phase voltage. Then I've got my B phase voltage. And I've got my C phase voltage, right? So you can see that here's the thing with these voltages, and we've talked about that before, you can learn so much from these vectors. And to give you an example, I'll give you a couple of examples here real quick. We talk about, since these are, you're using the positions of this on the circle here as far as what we're saying the degrees of the angles are. So we're using this, you call this 0. So we're calling this 0 right here, right? So if you do that, then if that's 0, then this is 90, right? This is 180, and that's technically, that's 360, right? Oops. All right. So here's what we do. Sorry, it's 270. What am I saying? So here's what you look at. So this is 0. All right, this is, so you're looking at the 0, 120, and 240. So you got 0, 120, and 240, right? Because I'm halfway between 90 and 180 here, all right? So 0, 180, 240. So here's what you do. If you look at that, we say on a cross phase, we say they're 120 degrees out. Well, if you think about that, that means that the relation between, if I look at my A phase vectors here, and I've got my current that goes with this, which would be my A phase current, 120 degrees out, which we say is cross phasing, means all of these vectors have moved over 120 degrees. So then that would mean this current vector moves over with this one, because remember it's 120 degrees and then 240. So if this moves over, I'm moving 240 degrees with this one, and then 240 with that one, and 240 with that one. Well, then what would happen is, if I looked on there, that's when I get the mistake of, if everything shifted 120 degrees, rather, sorry, then that would be, I would have, that would be over here. I would have my A phase current over here. I would have my B phase current over here. So I'd have my B phase over here, my B phase current right here, and then I would have get all my markers mixed up. And then over here is where I have, I'm just drawing these, not being exact. And this would mean my C phase current. So everything swaps, right? So I'm seeing where I'm not matched up on my vectors. I don't have the same color vectors on each phase, right? Because everything shifted 120 degrees, and that's the distance, that is the degrees between here, here, and here. So then that tells me I've got a cross phasing. We've talked about this on previous webinars. The 180, it's 0 and 180. That means then if I've got polarity reversal, right? If I've got polarity reversal, then that means, cover them up so they don't dry out. That means that this current has shifted 180 degrees. It's usually not exactly 180, but it looks something like this. And I've got my A phase current over here. It's going to be close to 180 degrees out, and that's my polarity reversal, right? That's when I probably got those secondary wires connected backwards on the CT. So that's where we get these degrees. We've got a 120 degree shift on a cross phase, 180 degree shift if I have polarity reversal on one of those phases. If you look here, you'll notice I've got 120, 120, 210. I've got much longer voltage vector on C phase than I do A or B phases, right? Because this is a high C leg. So that larger transformer up there on C phase, it also shows out on the equipment on the screen right here as being a much longer vector right there. And it's pegged out at the top because that is my open head vector, which is my voltage. My solid head is that's the current. So I can see here that I've pegged it out. I've got a much longer one on that high C leg than I do A or B when it comes to my voltages, okay? So that goes, in other words, you've got, like we've been talking about, you've got this checklist in your head, this Rolodex of going through it. Now that is matching what I'm seeing at the top of the pole. I've got the larger transformer on C. I've got, and I look down here on the test equipment, and it shows me a longer vector on C, which it should be because I should have more voltage on C than I should A or B, okay, because it's a high C leg. Okay.
You have a C high, you've got 210 volts on C phase, 122 on B, and 122 on A. So that's another way to look at it. And then you can look over here at the vector. On a C high, your vector on C phase, the blue lines, they're either going to be straight up or straight down on your skinny one right there on the
Yep.
voltage. So we look good here.
And we've talked about it a lot in the webinars and stuff. We say that there's two parts to these vectors, right? You're looking at angles between the vectors, so you're looking at that part of it, and relationships between voltage and current vectors on the same phases and maybe even other phases depending on what you're doing. But there's also the amplitude and how long it is, right? So if you look right here on this screen right here, you'll see I've got B and C. You can see how long they are. Look how much longer. We're always, right, the thin open arrowhead's always my voltage, thick one with the closed arrowhead's always my current. So if I look at that one, look how much longer that C is, right? And it corresponds over here to the actual values over here. So so you can see right here it is
right
twice. You know,
Okay, and one more thing. We've talked about this with vectors before, previously, about power factor. Okay, so the larger the angle, the worse the power factor to us as a utility, right? Because that bigger angle means that number is smaller. That's when you take the cosine of an angle, it becomes the larger the angle, the smaller the number. So when that happens to us, we end up multiplying. Remember, when we're trying to figure out how we're going to get paid as a utility company, we get paid on current times voltage times power factor equals watts. Well, when we do that, this number we multiply by, if it's a small number, I end up with less watts. If it's a larger number, I end up with more watts. And when it's 1, it's perfect. We're not losing anything. Okay, that means that all of this voltage and current that I'm supplying to that utility, I'm getting paid for every single bit of it. It never happens in the field, but I want that number to be as close as possible to 1. Okay, if it's 0.5, which is what you use on, remember that's one of the 3 tests that you use for a phantom load test, which is the power factor test out of those 3. We make it 0.5, which is horrendous. Okay, so we're talking about a 60-degree angle. When you get that big an angle, I mean, it's wide open. The cosine of 60 is 0.5. That's really bad. Okay, so what you want is you want a number close to 1, because as close as it gets to 1, I'm losing less, you can think of. So if we look at this screen right here, okay, it bears out what we're saying, because look at the difference in the size of the angle on A versus B. A lot bigger angle on A than it is on B. And if you come over here and look at the screen of the test equipment, right, you can see right here a much worse power factor on A than on B. So all of it, this is a great tool, one of the best tools that you have in the field are those vectors. It shows you a lot of things. We talk about what we mentioned before, cross-phasing. It shows you polarity reversal. And it also gives you an idea just visually when you look at it, especially when you have it, the color differentiated between the 3 phases. You can see it easily. If I see a big angle, I know my power factor is not good, and right here on the side of the screen right here, it bears that out in actual numbers. Okay, so I see here a much worse power factor on A than on B. Okay, thanks, JP.
No, at least twice as long, because I got 120 versus, what did we say it was?
211.
211. So you can see how much longer that open arrowhead on C phase is vector than it is on B or C. And that's because it is, almost twice as much. So you can see how much longer it is.
So as you can see, we're up to the point now where we're just about ready to start the test, and that'll be the third in this for this site. So you've noticed a lot of things that we're already bearing out before we've even actually started the test. We've determined the service type, right? Both visually looking at the top of the pole. Don't go off the paperwork. Don't go off what someone tells you. You check yourself with these and this, okay? So you look up there and you see one of the pots is larger than the other two. That's telling you you're probably looking at a high C leg, okay? So then you look up there because if the higher pot that you see up there is going to be a larger voltage like that. So in this case, it proved out to be true, okay? And we're going to see when we run the test how the test runs. Also looking at when you get ready to set up, I really like the way he had set up, even with table and laying those cables over the top of the lid. It's a great setup. Then he makes his connections, and you have the choice. You can work those alligator clips for the voltages and work them on those blades if you like, or if you've got some good teeth on there and want to go in the tab on the end of them, that's fine. Some of those older test switches, you've just got a short, little, thick piece of metal sticking out with no hole in it. I would go on the blade in that case because there's nowhere really for it to grab, and think about just those little points it's grabbing, okay? Right here on the end of this, it's just grabbing there on the end of that. I would want to work and get on the blade some, okay? And one thing I didn't point out, you notice he turns also those alligator clips, and I point out and talk about it more on one of the tests, so that it's not grabbing or hitting that long swing blade, okay? Remember, my shunt blade is a short stroke, and my return blade's a long stroke. If you put this where the long stroke return blade is a lot, you're going to hit it and want to knock it off of where you've got it connected onto that test blade on that switch, okay? So then you've got it set up, you make all your connections, everything looks good. Then you also take a look at the vectors then, those important vectors, and you look at them. And if what you're seeing up at the top of the pole should match up with what you're seeing on the screen. And if we see a high C leg up there, what we think is a high C leg, and we look down there and sure enough, that C leg open-headed vector, which is my voltage, is much longer, then that's all falling into place with what I see is, okay, I'm still feeling good about things. Nothing's causing me to go, whoa, 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 something's not right here, okay? So all of those things, before you really start running the test, it's just such a good idea to look at that and inspect inside there. You know, if it's two covers, take both those covers off. Leave your glove on when you're taking any of that stuff off of there, okay? And also have your gloves on when you start cutting the seals and even enter into there. Safety, 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 okay? So at this point, we feel really good. It's an 8S site. We know we've picked the right service type, which is 3 voltages and 3 currents. You saw the 3 reds, right, going across there, handles on there, and then off my neutral as well. Those 3 reds were just the long stroke voltage blades. And then I've got 2 blades each, 1 return and 1 shunt on each of my CTs there. So 3 voltages, 3 currents. I choose the correct service type on the piece of equipment, right? And I know it's an 8S, and it's a high C leg. So up to this point, everything seems to be matching up pretty well for me, and I feel good about moving forward with the test. If you had gotten to this point and some things didn't look right, then you need to check your connections, make sure you've connected it correctly, but also take a look at that site and make sure there's not something wrong there, okay? Don't trust the paperwork or what someone tells you. Use these and this, okay? So the next one that you see coming up next week on Tuesday, on the 4th, we're going to finish this and go ahead and run the test on here and see what kind of results we get. And then the following week, I'll be back from Mid-South Meter School, and I'll be back here to do this live. So we really appreciate you guys tuning in and watching these. Hopefully they can be helpful to you guys to do your job safer out there and keep everybody safe and getting home to their families. And we really appreciate the support. I really appreciate Brylan and JP who hung in there with me to do this. We've got Actually, Jonathan does some of the later ones when we finish this up, but those guys really did all the work. So, so thanks to them, and again, we just appreciate you guys tuning in. If you've got any questions, please send us in from anything you've seen on this one, and we'll address them going to the next one, okay? So if this is, you know, caused a lot of questions to be asked, then great, send them in to us, send them either to JP or to myself, and we will go ahead and address those before we start the next one, all right? So y'all be careful out there, God bless, and thanks a lot.